All right, everybody, let's go ahead and get started. Welcome to Computer Science 1. Hi, everybody. All right, I just wanted to welcome you to this special Snow Day edition of Computer Science 051. You are probably cozied up warm in your dorm room somewhere or outside playing snow football or sledding or doing something fun. I am sitting at home coming up with new slides and video presentations so we don't fall so far behind that we never catch up. So let's just go over what we talked about last few times in classes. Last class, we talked about strings, and we talked about strings having something called methods. A string method is a dot appended to the variable name of the string with the name of the method. One of the ones we looked at was the dot at. We'll take a look at this again in a second. We looked at dot length. Dot length tells you how many characters are in the string. The difference between dot at is that the numbers in the string, the letters in the string, are numbered not from 1 to how many there are, but from 0 to however many there are minus 1. 0 to minus 1 to n minus 1, whereas length returns n, the number of characters. We talked about doing file input. For this, we had to use the #include fstream, which gives us a bunch of different things. The ifstream object, which we used to read from, we called the open method on that to make sure that it was linked to a file. We were able to check and make sure that linking happened correctly, and then we were able to use the angle operator to read directly from the file into a variable. Then we talked about while loops, so that if we had a file that had a large number of lines, but we did not know how many, we could just use the while loop to keep reading things into the file as long as there were things in the file to read. And we went through this because we were a little bit behind already and because you needed it for your algorithm. So we kind of got ahead of ourselves. And what I'd like to go back now is go back and revisit a few things and give us a little more focus on some stuff that we need to take a look at for other projects. So let's switch over. And I'm going to start by looking at this code. And this code is a revision of one of the things that we did for strings. I'll pause here for a minute. You can pause the video and take a look. Also, the code will be uploaded to Blackboard under the name string.cc under the date 2014-02-13. But essentially, we declare a string variable. We get into your name, we get a name, we see out what name we got, and then we use these two methods at, 0, and length to find out what the string length was. So let's just make sure these are working before we go ahead and modify it. So I'm compiling the string.cc file. It compiles cleanly. Let's go ahead and run it and see what happens. So here we are. We have the opportunity to enter our name. Oops, let me just make this a little bit bigger. Typeface, so hopefully it'll show up on the video better. All right, so it compiled cleanly. And let's try and run it and see what happens. So we have a chance to enter our name. I enter Clay. And it tells me my name was Clay. The first letter, which was in position 0, was C, and the length was 4. So everything seems to be working fine. Well, what I want to do is I want to look at one other method for strings that can be useful. So let's go back to our code and take a look. What I'd like to show you is I'd like to show you what's called the substring method. And the idea of substring is that if you have a long string and you want to extract a particular portion, you use substring. And here's how it works. You call .substr for substring on there, and you give it two variables, and we'll call them x and y. And I'm going to just label in the comments here what they are. X is the place to start, and this is numbered just like at. This goes from 0 to n minus 1, where n is the number of characters in the string. And then y is the number of character to extract, and we'll call it copy. So let's do this. We'll call it string sub equals name.substr, and we'll start at 0 and go through, say, 6. Okay. And what we'll do is we'll output this to see what we got. Okay, so we made this change. The change we did is we added this substring method, .substr. We see out substring was angle, angle, sub, angle, angle, inline, and we return 0. So let's go over here. We will try and compile it to make sure I didn't introduce any gross errors. Whoops. Compile it. So it compiled cleanly. We'll run it. And this time we'll say my name is Georgetown. And here's what happened. It said the first letter is G because of the call to @ which, if you recall, was right up here, right? We said first letter, name @0, and the name, the @ starts in place 0 and goes to n-1. I keep emphasizing that because it's a little bit different than you might expect. The length was, and we'll see how the length was, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's correct. And it said substring was George, George. So if I jump back to this code, we can see that why it was. We said 0 was the place to start, which we knew from this .at was the first letter, and we said go 6 places. So when we start at Georgetown, the whole thing, we start at G and take 6 places, 1, 2, 3, 4, 5, 6. Obviously, we get George. All right. So substring is a method you can call in a string that will extract a particular portion of the string. Let's go ahead. I'll show you. We can get other things too. So we can say sub once we've output it. We can say name.substr, and this time we can go say 6, 4, and we'll output it again. And with luck, if I've done this well, we will get the town part. I'll clear, we'll compile cleanly, we'll run it. And we got George and town. Now notice this time, we said start in position 6. Since we start at 0, we go 1, 2, 3, 4, 5, 6. Ah, I just did that wrong, didn't I? Because I got to start at 0. 0, 1, 2, 3, 4, 5. And the 6th place is actually the T, and if we take 4, we get the town part. So, Georgetown. I hope that makes sense. Any questions? No? Okay, well, I'll keep moving on because you'll have to ask your questions in class next time. One common question that comes up when we reach this point is, if we can just have a string, and if we can extract things from a substring, why don't we do all our input using a string? And I'll tell you why. Say we were doing, CN of something that had multiple pieces, right? Like 3 numbers in a row that were separated by spaces. It's really annoying to have to look through the string in order to find the spaces, extract the numbers as strings, as substrings, and then you have to convert those strings which hold a number into an actual integer. Because a string holding a number is not the same as an integer. There are ways to convert between the two. I'm not going to show you how to do it. But most of the time doing string parsing to extract information is it's pretty annoying, which is why we use CN, because CN automatically breaks on spaces for us and separates things up for us neatly instead of reading everything as a string and going on. So I wanted to show you that about strings. Okay, let's move on to the next thing that I wanted to show you about strings. So here's a separate program. This one's going to be called string2.cc. And if you look at this, you can see it's a pretty simple program. We declare one particular string called named1. We call another string called named2. We say cout, enter first name, get line, cn name1. Cout, enter second name, cn get line name2. And all it does is print out that we got name1 and name2. So let's go ahead and test this and make sure it works. So it compiles cleanly and we're happy. We run string 2, enter first name, Clay, enter second name, Quinn. And so it's got name 1 Clay and named 2 Quinn, which is what we expect. That should be pretty straightforward. What I want to show you now using this code, I'm going to get rid of our output statement. What I want to show you is that it is possible to compare strings. Just like when we have greater than or less than or equal or greater than or equal or less than or equal to, you can compare two strings to see what they look like. So let's give this a shot. Here's what we're going to do is we're going to say if name1 is equal to name2, we're going to output that name1 and name2 are equal. Otherwise, we're going to check and see if one's greater than the other. We'll say else if name1 is greater than name2, and what we'll do is we'll see out that name1 is greater than name2. I probably need some end lines here, otherwise it'll be ugly. And then if we do that, we know that else, and here we can just say in a comment, name2 is greater than name1. And how do I know that? Well, because I know stepping through this first statement that if name1 is equal to name2, that they're equal. And if we reach here and name1 is greater than name2, then since they're not equal and they're not greater, the only thing that's possible is name2 is greater than name1. So here we will print out name2 is greater than name1. Whoops, gotta get that outside the comment there. Clean this up a little bit. I normally don't like inline comments like that, so we'll just do this. And what we will do is go ahead and output that name2 is greater than name1. All right, so what we've done is we're still inputting a first name, a second name, then we compare to see if they're equal, if one is greater than the other, or the other is greater than the one, if that makes sense. So we'll jump over here, we'll clear it, we'll compile it, clear, we will compile string2, it compiled cleanly, so we're happy, and we'll run it. So the first name is Clay, the second name is Quinn, and we say Quinn is greater than Clay. Now you might stop for a minute and say, why would Quinn be greater than Clay? And here is the answer. If you remember back to when we talked about characters and how each character was represented by a code, what the string comparison does is it actually compares the value of that code. So let me show you some example. In this case, what happened was Quinn, the letter Q, had a higher ASCII value than Clay, the letter C. And so it said Quinn is greater. But if we did something like this, it said Clay is greater than Quinn. And the difference is that now the first letter in there is lowercase. And lowercase has a higher ASCII value. So there's this weird thing that when you sort strings, they do not always compare exactly the way that you might expect them to. Because when they're getting compared by their ASCII code rather than, say, alphabetically or anything like that. So what ends up happening is lowercase letters end up being greater than uppercase letters, things like that. Let's just try a couple of others here. Let's try first name is Aaron, and the second name is Aaron. And it'll say they're the same, right? Because Aaron and Aaron are exactly the same. But if we do this now with uppercase and lowercase, lowercase is going to be greater. Because what it's doing when it compares is it looks at each character and it says, are the first characters the same? They are. Are the second character, and this, excuse me, in the case where they're using two lowercase letters, it looks, it goes, is the first character the same? Is the second character the same? And if so, they're all equal. But again, it's comparing these ASCII values, and when it looks and it goes, oh, this thing is equal and this one is greater, it will tell you that they are greater than. So it is entirely possible to compare strings, except when you compare them, it does it in a way that you might not expect because it compares them by ASCII value. And if the first ASCII value is tied, then it goes on to the second. Let me show you a couple other things about this. So AARON is the first name, AARON underscore is the second name. And it will say AARON is greater because the underscore appears before the space. And if we know the ASCII value of different things, we can try it. AARON at, and then I think AARON underscore. Well, underscore is greater. And what it's doing is it's comparing each string letter by ASCII value, and then, and only then, it is trying to figure out which one is greater than the other. Okay, that's all that I really wanted to show you about strings. We didn't have time to go over it in that class. So what I did is I showed you a couple of things. I showed you the substring method. And remember, the substring method has two things inside the parentheses. The first is the position in which it starts. And this position, just like the @ starts at 0. And then the second thing in the substring is how many characters to take after that. Okay? So I normally have an exam question on that, so you can expect that. The next thing we looked at is string comparison. And we saw that for string comparison, it goes by ASCII value. It compares each ASCII value in sequence. And as it goes through, it decides which one is greater than or less than. And this results in things not always being sorted the way you would expect, because lowercase letters are always going to be greater than uppercase letters. It's not alphabetical at all. And then there's other things in there too that make it weird, because the different printing characters and spaces and such have values of their own. All right, so that's all we're going to talk about for strings this semester. I hope this was helpful, and we're going to move on and talk about some other things now. Okay, so we've revisited strings, and we've looked at a bunch of different things there. What I'd like to do now is go back and revisit some other things about file, input, and output. So here I have the program that we wrote before that will input a particular type of animal. Okay, now that we've looked at, revisited the things on strings that we didn't have time to cover, I'd like to go back and revisit something about file, input, and output. So let's just take a quick look at this program. It's very similar to the things that we looked at in class when we were talking about file I/O. And here's what we have. Here's our algorithm. We started at main. We have a variable that represents the file, which is of type ifstream. And remember, of course, you need fstream at the top for this to work. We connect that variable to the file using the .open method. And in this case, we're reading datafile.txt. Let me just switch over to the datafile.txt file. It's similar to what we're working on before. It's just got a list of single animal names is what we're reading. So the data file exists, and it's a list of single animal names. We check that the file opened correctly, and for this we say if not input file, we can output the file not found. And if we get here, down below that, we've skipped over the return, and so the file is opened. And here's what we're going to do. We're going to create a variable that holds what's coming in from the file, and we're going to use our while loop to input things into a particular variable named animal, and we're going to print out each one. So this is a pretty simple algorithm. It creates a ifstream object, opens a file and links it to that object, checks to make sure it works, then reads single strings out of the file and outputs them. So let's just go take a look and make sure that this worked correctly. Hey, where's my... So let's take a look. File IO is the name of it. So we will compile it, g++ fileio.cc.o fileio. It compiled cleanly. And when we try and run this, we should get a list of everything that was in the data file, one line at a time. Cat, dog, moose, rat, snake, bird, iguana, frog, nematode, dragon, unicorn, lion, shrimp, bear. So that seems correct. So our program is working correctly so far. So here's what I would like to show you now. I would like to show you that not only can you use this to read data from a file, you can also use this to write output to a file. So in this case, we're reading from a file, but we might also want to read stuff to output stuff to another file. Let me show you how you do this. It's very similar. What we're going to have instead of an IF stream is we're going to have something called an OF stream. IF stream is for input file stream. OF stream is for output file stream. So just like we had to open the input file, we're also going to have to open the output file. So let's give that a try. And in this case, what we're going to do is we're going to say output file.open, and then we're going to call it output.txt. Then, just like we checked before, we're going to say if not output file, if bang output file, not output file. we're just going to give it the same error message, except we'll give it a little clarity by saying output file. Okay. And then what we do is once we have that file open, we can output exactly like we could using cout. So we replace cout with output file, and it says animal was. Okay, so here's our algorithm. We have an IF stream, which is going to be the input file. We have an OF stream, which is going to be the output file. For each one of these, we have to connect them to the file that they're going to be using. So we use the open for that, input file.open, data file.text. And if that didn't work, we say file not found and exit. Output file open, output.text. And if that didn't work, again, we exit. Now if we get down here, the file opened, string animal, and we say input file into animal, output file animal was. And this should read things from the input file, put them in the animal variable, and then write them to the output file saying animal was and whatever we read. So hopefully that'll work. Let's just take a second and compile and see. It compiled cleanly, so we're happy. And when we run it, here's what we see. There was no output. And why wasn't there any output? Well, if you were paying attention, it's because we did not have any couts. We only had this output file. And the output file name was output.text. So instead of outputting to the screen, whatever was normally going to appear on the screen is now going to appear in this file, output.text. Let's go back and see if it's there. So ls tells me all the files there, and hey, here's output.text. And if I type more output.text, it will just display on the screen what was in there, and that is the output we were expecting. Except instead of going to the screen, it went to the file. Does that make sense? So we can absolutely, positively read from a file and output to a file. Now the question often I've seen comes up and says, hey, what if you want to output to the file and also to the screen? Well, that's actually pretty easy. You just need one line that will output to the screen and one line that will output to the file. So you can mix these couts and output files together, and each one, because the computer is just a dumb machine that does things very fast, each one of these will kind of do the right thing and put the data where it is supposed to go. So that's everything we need to know about file input and output. Let me just see if this works, except for one thing, which we'll look at in 1 second. So we'll go back, we'll compile. Let me just show you something. We'll remove the output.text file. We'll do ls, and you can see there is no output.text file. It's gone. I deleted it using the rm command, which is short for remove. So we will compile the file now, and I will run it. And you can see this time everything was output to the screen, and the reason it was output to the screen was because we had a cout that output things. But if we look, we should also see this output file having the same thing. So let's go take a look. If we do ls, you can see output.text has appeared again. And if I say more output.text, it has the correct output. So that is file input and output. There's one other thing that you need to know for file input and output, and this is just good programming practice. You can open a large number of files on most systems, but the number of files you can open is limited. And often, when you're opening these files and working with them, other programs will not be able to access those files. So what's polite to do and what's good practice is to call the command that disconnects from the file. And anybody want to guess? If opening is connect, if open connects to a file, what do you suspect will close the file? I'm by myself, so I can't call anyone. I'll just tell you the answer. It is close. So you can say input file.close and output file.close. And what will happen is that once you're done reading and writing the files, this will say, hey, we're done doing that. Now, in a small program like this example I've given you here, you don't really have to close these files because once the program stops, the operating system automatically closes the file for you. But since we're trying to teach you good programming practice, it is something that you should do. When you're done with a file, you should close it. Okay, so let's go ahead. We can run this again. I'll show you that it compiles correctly. Now that we've added that, still compiles. And when we run it, we're going to see exactly the same thing. The difference is not going to be visible to us now, but it's important to get in the habit of adding close to the end of when you're doing things to the file. Okay, while we're going around revisiting things, I would like to revisit one more thing, which was the while loop. We saw the while loop only in the context of how to read things from files. But you can use a while loop for quite a lot of different things. So let me just call up a file here that we can use, and I will call this one while.cc. And, you know, pound include IO stream, yada, yada, yada. All right, so here we've made our default program that does nothing, and let's start making it do some stuff. So when we talked about the while loop, remember it looked like this, while, and then we had some Boolean condition in here. And then we had curly brackets, and we had what was called the body of the loop, and the body is whatever the loop does over and over again in there. So it looks almost exactly like an if statement, except instead of only doing something once, it does it as long as this Boolean is true. So let's take a look at some of these loops. So let's write a while loop. Let's say we have int x equals 0, and we want to count. And we'll say while x is less than 10, we will output x, cout x. And we need to make sure we increment x, otherwise something bad will happen, which we'll look at in a second. So this is another example of a while loop. It's a pretty simple one. We start with a variable int x equals 0. We say while x is less than 10, we output x, and then we increment x. So let's just make sure that this compiles correctly. Compiles correctly. Hello. All right, it compiles correctly. Let's run it and see what happens. Here it starts at 0, and it's saying while it is less than 10, increment it 1 every time. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go back and take a look at the code and make sure this is what we expect. So we start with x is 0. The condition is x less than 10. So the computer looks and goes, x, oh, I have this box named x up here. It's called 0. Is 0 less than 10? The answer is yes. Since the answer is yes, it goes and does this, and it outputs 0. And then x plus plus adds 1 to x, and it is now 1. We go back up to the loop. It says, is x less than 10? Well, we check what x is. X is now 1. 1 is less than 10, so it outputs x. Increments. X is now 2. Is 2 less than 10? Yes, it is. You can see where this is going now, right? 3 is less than 10, so it outputs 4 is less than 10, 5 is less than 10, 6 is less than 10, 7 is less than 10, 8 is less than 10, 9 is less than 10, so it outputs 9. It increments x plus plus to be 10, and it looks and it goes, hey, is 10 less than 10? And the answer is no, 10 is not less than 10, so the loop stops and it returns 0 and the program ends. So this worked kind of exactly how we wanted it to work, right? It said 0 through 9 and everything was good. All right, so that's one thing that you can do with a loop. You can have a counter and you can do things a certain number of times. Let me just show you what happens though if you make a mistake. Let's say we make a mistake, instead of plus plus, we put minus minus here. Now think about this for a second. If we start at 0, 0 is less than 10, so it's going to output 0. And then it's going to take 1 away from x. Well, 0 minus 1 is minus 1, which is less than 10. But you can see that instead of growing x and getting it closer to 10, we are decreasing x and getting further away from 10. And in fact, x will always be less than 10. So if we try this, let's just take a look and we'll run it now. We'll compile it and make sure it works. It compiles cleanly, and we run it. What we're going to see is it will just run forever. And you can see how fast the computer is, because every time it's flashing the computer, it's counting about 100,000 times a second, which seems slow given the number of calculations the computer can do, but it turns out that output to the screen is very slow compared to addition. So you can just see it's counting down incredibly fast. This is what's known as an infinite loop, because it's going to go on forever. Eventually, if we let it run long enough, the number will get out of the range of what an integer can safely represent, and something weird will happen. Probably the program will stop or crash. We're not going to wait that long. So that is your example of an infinite loop, one that goes on forever. The question people often have in an infinite loop is, when this is running and you have an infinite loop, how do you stop it? If you ever make a mistake and do that, well, on CS class and on my computer, if you're working in the terminal on Mac, you hold down the control button and hit C, and you can see this thing right here, control C. That caret means control, stops the program while it's running. So if you ever get into an infinite loop, you can stop it using control C. So let's go back here and take a look at this. While x is less than 10, C out x, and all. So you can see that what we're doing here is looping a certain number of times. So what else can we use this for? So let me show you something here. Let's try this. We're going to create a string name. This might be familiar. We'll say C out, enter a name, and then we'll say get line cn and name. All right, what this is going to do, this should be familiar, is output prompt someone for a name and then enter a name. And what we're going to do is we are going to, in the loop, look at every single letter of the name one thing at a time. All right, so what we're going to do is we're going to say x is 0. And we're going to say while x is less than name.length, length. Now remember, this method tells us how many letters were in the name. And what we're doing here is we're going to say while x is less than name.length, output name.at x. And then instead of x minus minus, we want x plus plus. So what this should do is it should loop over the string name and each time print out one letter from the name. Does that make sense? Let's take a look and try it and see if it works. So we'll compile it. It compiles cleanly, even though I forgot the string.cc up at the top, because my Mac will remember that, even though CS class will not. So we enter a name, we'll call it Frank, and look, it prints out one letter per line, F-R-A-N-K. So go back and take a look at the code. You can see that I forgot pound include string, and I can get away with that on a Mac, but you can't get away with it on CS class. So this while loop, where we count a particular number of times, is very common. This type of operation where we do things is very common. And so we have a special type of loop instead of a while loop that does this thing. Well, let me rephrase. So the while loop is good if you want to do something an indeterminate number of times, like reading lines from a file. You don't know how many lines are going to come from the file, so there's no use setting a counter to do that. All you're going to do is keep reading it. A while loop is also good for things like getting input from people. Like if you get input from people and they make a mistake, you can go back and say, hey, you made a mistake, try again. And how many times does it take people to get things right? Well, who knows? People range from imperfect to suck, so it could take a very long time. We don't know the exact count. For other applications, though, like traversing all the letters in the name, you want a counter. Now, this type of loop where you do things a certain number of times is so common in computer science. It's incredibly common that there is a special type of loop just for that, and it's called a for loop. A for loop is for when you have a specific number of times you want to do something. Okay, and a for loop looks like this. It's a little more complicated. It's got the word for, open parentheses. It has some start condition. It has a Boolean. and it has an incrementer. Okay, so we have a start condition, a Boolean, and what I'm calling here an incrementer, and we have a curly bracket. We have the body of the loop, and we have the closing curly bracket. It looks just like that. So let's rewrite this loop we did up here, the while loop, as a for loop. And again, for loops are really good for this type of thing. So our start condition is we have some integer x, which I'm going to use L down here for length equals 0. We're going to say L less than name.length and L plus plus. Now you can see the same thing we had in this while loop. We had an initial counter, which we have down here. It's our start condition. We had the Boolean, which is this x less than name length, which we also down here, L less than length. And we had this incrementer, which happened at the end, which happens right here. Okay, this is a compact notation for a loop that does things a certain number of times. And then we could have exactly the same output here, cout name dot at, in this case L, and DL. Okay. All right, let me just clean this code up a little bit because I didn't like what happened there before. All right, so now what we've done is we have a get line and we are traversing, we are iterating, and this is what it's called when you do things in a loop a number of times. It's called iteration. So we're iterating over the string name and looking at each letter in turn. And first we do it using a while loop, and then second we do it using a for loop. Okay? Second we use it during doing a for loop. So let's take a look at this, and we will compile again. Whoops. Looks like I had an error in there, and you know what? Without all you there to yell at me for my error, I get things backwards. Let's see, invalid operand. All right, line 29. There's no such thing as end, but there is something named endl. So I had that little typo there, which generated that quite impressive string of errors. Let's see if adding the L there corrected it. Yes, it did. I warned you, didn't I, the first day of class, that the G++ compiler was not a very polite piece of software. Now, if we run this, just to revisit this here, what we're going to see is we're going to have a chance to enter a name. We will print out everything letter by letter using the while loop, and then we will print out everything letter by letter using the for loop. So here we go. Clay, and it says Clay, C-L-A-Y, from the while loop, and Clay from the for loop. So that's just an idea of how you do these things. So again, a while loop, even though we're using a counter here, isn't a really common way of using this. A while loop is almost always used if you have an indeterminate number of things, reading input, reading lines from a file. If you have a set number of things you're going to do, and in this case we know how many things we're going to do because we're going to do it however many letters are in the name, it's better to use a for loop. All right. So let's just do this a little bit differently. Once you do this, once you have a for loop, you can do things a different way, right? So we can actually say, if we want to reverse it, right? So that instead of, if we want to reverse it, instead of going in order, we can do things backwards. So we could say name.length. So we're starting at name.length, -1 actually. And we're saying while L is greater than 0. And instead of doing plus plus, we do minus minus. Now, look at this for a second. Here's our start condition. We declare an integer with L named length -1. While L is 0, the loop's going to keep doing things while L is 0, and each time we're going to decrement 1. So let's run this for a second and see what happens. And when we come back, I will explain why we have this -1 there, okay? So we compile it. It works. And when we run it, enter a name, Clay, you'll see, oh, what the hell, oops, sorry, I changed the code so that I could upload the two different versions of the code. So I named that one while2. I actually ran the wrong version there. Okay, that's much better. All right, now when I enter Clay, it says Clay, C-L-A-Y, and Y-A-L. What was my mistake? Why did the C not show up there? Let's go take a look at the code. And we say while L is greater than 0. So my mistake here was that L was greater than 0. It should have been greater than or equal to 0 because the C is in the 0th place. Remember, all the places in there are numbered 0 to n-1. So let's see if that helps. Clear the screen, we'll recompile. That worked, we'll run it, we'll say Clay. And here we say Clay, C-L-A-Y, that's the while loop that's outputting thing. And Y-A-L-C, which is the for loop that instead of running from 0 to n-1 is now running from n-1 to 0. So let's revisit quickly why there's a -1 there. Remember, when you have the string method length, it tells you how many letters are in there. So if there is Clay, then we know the length is 4. But when you use the method, everything goes from starting from 0. So instead of having 4, it goes from 0 to 3, 0, 1, 2, 3. And so if we said didn't have this -1 here at name.length, we would get an error of some kind because there is no position 4 in the name Clay. There's only 0, 1, 2, and 3. Let's take a quick look and just see what that error is. I don't remember off the top of my head. When we run it, we'll say Clay. Oh, look at that. Out of range basic string. So, so the string library said, hey, you did something wrong. That sucks. And it died. And the reason for that was because we were looking at the wrong place in the string. All right. Okay, so that is what I wanted to show you about for loops as well. All right, so that's about all I want to cover on our special Snow Day edition. I went fast. We will have to have some question time at the beginning of class next time. But this video will be online. You'll find out about it, obviously, because you're watching it. I will post the code that I've written up online as well for you to look at. Let me just mention one other thing. You might want to, and by might I mean strongly suggest that you do, read some of the textbook about this. And in particular, let me make this big enough so you can see it. In particular, you want to read chapters 8, section 1, 2, and 3. You want to read chapter 4, 1 and 3. These are about loops. And particularly, you really want to read chapter 4, section 2, which is about tracing code. When we come back to class next week, I think I'll probably have a bunch of handouts for you so that you can get some practice on this and I can make sure that this type of lecture worked. Anyway, have a good weekend. If the weekend's not already over by the time you watch this, I'm going to get this posted and have a good weekend myself. I will talk to you all later.